Good morning to all. Today we discuss about the topic is data structure. What is meant by data structure is way of collecting and organizing the data in such a way that can perform the operation of this data is effective manner. Data structure is formally defined by D, F, A. What is meant by D is set of the data object, F is a set of the function, A is assumptions to implement these functions. Next is why we need the data structure. Data structure is an important way of organizing the data in computer. Next is the different way of storing and organizing the data is effective manner. Next, help us to understand the relationship of the data element with another one. Next is it help to store the data in the logical order. Next, we move on to abstract data type. What is meant by abstract data type is in term of the data items or operation rather than by the implementation. Next, we see it is just the mathematical model which specify the logical properties and operation of the data types. The advantages is abstraction, encapsulation, generalization. Next, we see the classification of data structure. Data structure can be classified by primitive data type and non-primitive data types. In primitive data types can be classified by integer, real data, character, string and pointer. In non-primitive data type can be classified by three way. One is the array, next is the list, next is the files. The list can be classified by linear and non-linear. The linear data types can be classified by stack and queue. Non-linear can be classified by tree and graph. Next, we move on to what is meant by primitive data structure. What is meant by primitive data structure is it's a basic data type that available in the most of the programming language. It represents in the single way. The example integer, character, string, boolean. Next, we move on to what's a non-primitive data structure. Non-primitive data structure is derived from the primitive data structure. That means primary data structure is known as non-primitive data structures. Next, the data types used to store the group of the values. Example array, structure, union, linked list, stack and queue, etc. Linear data structure. In linear data structure, the elements are stored in the sequential order. Linear data structures have the array, linked list, stack and queue. What is meant by array is the collections of the data of the same data type stored in the consecutive memory location, and it also referred by the common name. Next, we move on to linked list. What is meant by linked list is collection of the data of the same data type, but data item need not be stored in the consecutive memory locations. Next, we move on to stack. Stack is a mechanism is last in first out. It under the linear data structure, we have performed the insertion and deletion operation in the queue. The only one in called is the top of the stack. Next is a queue. The what is in the queue is queue mechanism is first in first out. It under the linear data structure. It take the insertion at the one place, deletion at the another place. This is the difference between stack and queue. Next we move on to non-linear data structure. Elements are stored based on the hierarchical relationship among the data. The non-linear data structure can be classified by tree and graph. What is meant by tree is it represents the data, some hierarchical relationship among the data elements. Next we move on to graph. What is meant by graph is it is a relationship between the pair of element, not necessarily hierarchically in the nature. This example is electrical and communication networks and airplane routes and flowchart graphs and planning for the project. It's the best example is a Google map. Next we move on to what is the operation in the data structure. First is the insertion for adding the element. Next is the deletion. We have to remove the data from the data structure. Next is the searching. Searching is the finding the location of the data within the data structure. Next operation is sorting. It arranging of the data in the some logical orders. Next is the traversing. The traversing will be mainly performed in the graph. The data structure is accessing the each data only once. Next is the merging. It combining of the two similar data structures. Next we move on to tree and graph. We have to discuss about what is tree, what is binary search tree, traversing tree, and what is a graph, what is the difference between directed and undirected graph, what is the application in the graph. Next we discuss about the tree. The what is meant by tree is it is an undirected graph which have any two vertices connected by exactly one path. The tree can be mentioned as first node is a root node, the remaining node is a children node, the last node is a leaf node. The different technologies are used in the tree. The one is a root, next is a parent, next is a child, last one is a leaf node. Next we move on to binary search tree. What is a binary search tree is? For fast insertion and removal of the element, we move on to the binary search tree. Next, traversing tree. The traversing tree can be classified by the three way. One is a pre-order, one is a in-order, next one is a post-order. They have the three mechanism. The pre-order is root, left, right. In-order is a left, root, right. Post-order is a left, right, root. The what is the application of the tree is life system, storage large volume of the data, artificial intelligence, compiler design and text processing. Next we move on to graph. The what is meant by graph is it's a set of the node and edges is called as a graph. The directed and undirected graph is one. We have the direction. The direction is called as a directed graph. There is a no direction is called as an undirected graph. This is a best example for directed graph and undirected graph. The application of the graph is driving map, airplane traffic. Next is the computer network, internet web graph, this and all. This is a basic concept in data structures.